Hi friends, welcome to our channel. Here we are going to look at problem 3396, minimum number of operations to make elements in array distinct. So here the operations is remove 3 elements from the beginning of the array. And if there are less than 3 elements, we're going to remove all remaining elements. So here, the problem size is very small, because the length is bounded above by, say, 100. So 100 divided by 3 is 33 modulo 1, right? So at most, you need 33 operations, because this 33 operations will remove 99 elements. So if you just have one element, for sure it's unique and distinct. So because of the small size, so we can solve it using brute force, but it's not our ultimate goal here. So our plan will be the following. So first, solve with brute force. So actually, sometimes it's an ability that you solve a problem using brute force. It's not trivial. Secondly, I'm going to use a dictionary to monitor to do the job. This will be not pure brute force. So now let's first look at the problem 1, example 1. So for example, this is not, you have so many 3s, for sure not distinct. You do one operation, you get this one. This is the remaining one. And then you do another operation, you delete 4, 2, 3. So you have 3, 5, 7. So this will be distinct. So you can do this brute forcely and then check uniqueness. So for this one, you can delete this one, and then you delete the 4s, you get an empty one. So empty string is regarded as distinct, right? So this one, you don't need to do any operations. So output will be 0. So now I'm going to do it in brute force way. So this can be very straightforward. Well, nums, then if the length of set nums, so this contains the unique element, equals the length of nums. It means all the elements are unique. So we're going to, so let me see a number of counters. So it's going to return the current state of C. So otherwise, so what do we do? So else. So we do del nums, so up to this. So we are going to increment C by 1. And then finally, we just need to return the state of C. So you can check. It will pass all the cases. So notice that if your list have less than 3 elements, this will delete all the things. So you can check, you can print out the nums. So then you can afterwards so you can see we can use example 1, right? Before deletion you have this one, and after deletion you have this one. Then before deletion you have this one, after deletion you have this one. And then let's look at this one. So before deletion you have 5 members, so afterwards you get this. But now the length is 2, right? But you can still use this operation, because here it just deletes all the 2 elements. So this is the one way, but this is 2 brute force, because we brute forcefully check this for uniqueness. So I'm going to copy this part and then change this one to be version v1. So here I'm going to use dictionary. So essentially, I'm going to use a counter, right? So first, counts. So we can use collections, say counter. So it's nums. So this will give you the unique elements and their corresponding frequencies. And also we have multiples. So we want to find those key value pairs which appears multiple times. So you can do num and the count for num count in counts items if count is greater than 1, right? So you can print out this. So multiples. So let's see. For example 1, so 2 appears twice, right? 3 appears 3 times. It's due to these numbers which appear multiple times that we do not have uniqueness, right? So now let's see what we do, right? So we're going to comment out this. And then, so val multiples, right? Then we're going to do some delete operations. So first, we have the length, right? The position, the number of operations. So operations, so we just set it to be 0, and total will be the length. So I'm going to use length nums. This is just for convenience. And then what we do? So once we have multiple, this is not empty, meaning that there are elements appears more than once. So what we're going to do is operations is incremented by 1, right? Then we're going to delete at least 3 elements if possible. Otherwise, we delete what we have. For this in range 3. And then if position is greater than or equal to n, right? So then in this case, so we just break. There's no elements. Otherwise, so the current will be nums position. So this is the one we are going to delete. We don't need to, actually delete the number from the nums. So we just monitor the change of this this dictionary, right? If current in multiples, if this number appears multiple times, then we monitor. If it just appears once, of course, if you delete that, it just disappear, right? So then the multiples of the current will be decremented by 1. And then if this number, after you do decrement, so it equals, say, 0. So we're going to delete this key. Right. So once we have this, so what we are going to do? So once we do for this one, and then once we delete 1, so we're going to do position increment by 1, right? And then we have already incremented this operations. So now we just need to return the number of operations. So this is essentially the same as the first version. But when we check, we replace this condition to be this condition here, right? This is much more delicate and more refined. Let me do a run. It's wrong. Let's see what's the problem. So here, operations 0. So operations increment by 1, and then we have so as this is a non-empty, so we do this, right? So let me check that. So we have operations this 3, and then position, then we're going to break, right? So current this if this greater than current this number, if current in multiple current minus 1. So no, it's not 0. So if it's just once, so we're going to delete this, right? Because we just need to appear just not more than once. Yeah, it passes the cases. Now let's look at the generic case. Yeah, it passes all the cases. So if you you can actually do some print. So for example, here print before deletion, the state of the multiples. I'm not going to monitor other things, just this guy. And then we have this one. So this is the after deletion, right? So let me print out some empty space so you can see. So this is the after we delete all those one, right? No, it's because originally 2 appears twice and 3 appears 3 times. So after deletion, so 2 appears once, right? It will not appear in the key. And the 3 appears twice, so it's going to be appear in the key. Then you delete again, you get 0. So for case 2, for example, so the 4 appears 3 times, and then if you delete this 3, 4 appears twice. So then if you delete again, so nothing, right? So for case 3, so because it does not enter this while loop, because multiples is empty at the very beginning, so you get 0, 0. So with that said, I guess that's it for the current problem. I guess this problem, as a comment, is an easy problem. So you can solve it using brute force because of the problem size. However, so the problem is provides us good context to practice the use of dictionaries, especially here. So we monitor the multiplicities. So here, let me make another comment. For some coding problems, for example, you need to get the max frequency. So the element corresponding to maximum frequency, and then you might need 2 dictionaries. One dictionary is the unique elements and their frequency, and the dict 2 is actually like here, right? The multiples is the frequencies and the unique frequencies, and their the frequencies. So actually using 2 dictionaries sometimes are not necessary. But the 2 dictionaries, so if you are using 2 dictionaries like this, Dict 1, Dict 2, are very powerful. So I hope that if you do a lot of practice, you can have such a intuition or feeling. So with that said, I guess that's it for the current practice. Thank you for watching.